Deep learning is a branch of artificial intelligence that teaches computers to learn from large amounts of data by recognizing complex patterns. It is built on the concept of neural networks, systems inspired by how the human brain processes information. What makes deep learning special is that it uses many layers of these processing units, allowing it to learn at multiple levels of depth. Deep learning powers many of the tools we now take for granted: voice assistants, image recognition in smartphones, movie recommendations, chatbots, self-driving cars, medical imaging analysis, and more. It is one of the key engines behind today's AI revolution. For decades, computer programs followed explicit rules. If X happens, do Y. This works well when tasks are clear and structured, like solving math equations. But many tasks in the real world do not have simple rules. How do you describe the difference between a cat and a dog in numbers? How do you explain to a computer what sarcasm sounds like? How do you tell a machine how to recognize a disease in a medical scan? These tasks rely on patterns that are hard to write as rules, but can be learned through examples. Deep learning excels at learning patterns from large data sets. Imagine teaching someone to recognize music genres. Instead of defining every musical feature, you play many songs and label them. This is jazz, this is rock, this is classical. Over time, the listener begins to notice things. Jazz has certain rhythms, rock has prominent guitars, classical has orchestral instruments. They learn the patterns implicitly. Deep learning works the same way. It does not need rules. It learns directly from examples. The word deep in deep learning refers to the number of layers in a neural network, not complexity in the philosophical sense. A shallow network has 1 to 2 layers. A deep network may have dozens, hundreds, or even thousands of layers. Each layer learns something more abstract. Early layers learn simple patterns like edges and corners. Middle layers learn shapes like circles or textures. Deep layers learn full structures like faces, cars, or animals. By stacking these layers, the system gradually learns high-level understanding. Deep learning learns by adjusting internal connections through repeated practice. The system makes a guess. The guess is compared to the correct answer. The system adjusts itself to be slightly more accurate next time. Repeat thousands or millions of times. Over time, the deep learning model becomes very good at understanding the data. This is similar to how humans get better at a task by practicing repeatedly. The core ideas behind neural networks have existed since the 1950s, but deep learning only became practical in the last decade. 3 major changes made it possible. 1. Big data. The internet produced enormous collections of images, speech, text, and video. Perfect training material. 2. Powerful hardware graphics processors and specialized AI chips allow models to train very quickly. 3. Better algorithms. Researchers developed smarter training methods and network designs. Together, these advances transformed AI from a research idea into real-world applications. Deep learning drives many modern technologies. 1. Speech and voice Siri, Alexa, Google Assistant automatic call transcription, real-time language translation. 2. Vision smartphone face unlock medical scan interpretation, self-driving car cameras. 3. Text and language ChatGPT and other conversational AI email spam detection, autocomplete, and grammar suggestions. 4. Recommendations Netflix movie suggestions, TikTok video feed, Amazon shopping recommendations. Anywhere patterns exist in data, deep learning can help. Advantages of deep learning: learns automatically with no need to manually define rules. Handles complex data, working well with images, sound, video, and text. Improves with data. More data leads to better performance. Generalizes well, adapting to new examples it hasn't seen before. Deep learning is especially strong at perception tasks, recognizing, classifying, and generating patterns. Challenges of deep learning: needs lots of data, as performance depends heavily on dataset size. Computationally expensive, requiring powerful hardware for training. Opaque decision-making, making it hard to explain why it makes certain predictions. Bias risks: if training data contains bias, the model learns that bias. Researchers are actively working on explainable and fair AI to address these challenges. Deep learning is now being integrated into nearly every industry. Healthcare, diagnosing diseases from scans and genetic data. Transportation, automating vehicles and optimizing logistics. Finance, detecting fraud and predicting market movement. Education, personalized learning systems. Entertainment, AI-generated music, art, and media. As models become more efficient, deep learning systems will move from cloud servers into everyday devices, phones, appliances, cars, and even wearables. Deep learning is a powerful branch of AI that teaches computers to learn patterns from large amounts of data. By stacking many layers of artificial neurons, it gradually builds understanding, from simple shapes and sounds to complex ideas and tasks. It excels at vision, speech, language, and decision-making problems that traditional programming cannot easily solve. In simple terms, deep learning allows computers to learn the way humans learn, through examples, practice, and patterns, leading to intelligent systems that can see, hear, speak, understand, and make decisions.